So for that, what we do is we just put one extra condition, and that condition is summation alpha I equal to 0. Now this condition is what makes that interpretation possible. That is, mu is now the average yield for the crop irrespective of varieties. So when you are averaging over all the alphas, you will get nothing but 0. That is why we put the condition summation alpha I equal to 0. So now out of the 3 alpha i's, only 2 remains free. The third one may be obtained from them. So under this restriction, you can of course uniquely obtain mu alpha 1 and alpha 2. And the interpretation here is mu is the overall mean effect and alpha I is the additional effect of variety I. Notice the term additional or extra effect due to variety I. In the first version of the model, alpha I was the mean effect for that particular variety. And now it is the additional effect for that variety. Sometimes, however, we want to write it in a slightly different form, and then we use this formulation. Same model, but the condition changes to alpha 1 equal to 0. We'll do this if, due to some reason or other, we believe that variety 1 is something like a benchmark variety. Suppose variety 1 is something that the farmers are already used to. That is the thing that is typically used, and the second and third varieties are new varieties that are going to be introduced by the government, and this study is basically trying to guess or trying to estimate which variety, whether these other two varieties are better or not. In that case, taking alpha 1 equal to 0 is a good idea, but now the interpretations will change. Now, the estimated value of mu will be the benchmark value. So it will be the benchmark value, that is the thing which you are already accustomed with. Because I have taken alpha 1 equal to 0, so the average now for the first variety is just mu. Mu plus alpha 1 is 0. So now mu has the interpretation of that benchmark value. And alpha 2 and alpha 3 will give you the additional effect of varieties 2 and 3 over that benchmark value and not over the overall mean effect. So all these formulations are essentially the same. If you can fit any one using a software, you can immediately fit all the others. It is just a little question of manipulating the coefficients. Unfortunately, I have seen many people getting completely confused with which formulation should I use. That depends completely on what interpretation you want to give to the various coefficients. For example, if you have in mind that alpha 1 should reflect the average yield obtained by variety 1, and by mistake you have used that particular thing where you are putting summation alpha equal to 0, you will get alpha 1 hat, possibly something negative, and you will be surprised. What does that mean? If I sow this particular variety, then I get negative yield? That's just meaningless. So make sure what interpretation you are attaching, and that will dictate the particular form you are using. So far as the statistics goes, the goodness of fit goes, all those things are equivalent for any of these things. And in a software, you typically do not see that you will fit this version or that version. Most softwares will fit one of the versions of their favorite choice, and you have to recast it in your particular form of parameterization.